Okay, this is section 6-7, and this is our last section of the year actually, and we are going to be looking at dot product. Now we've been looking at vectors and what we can do with vectors, and what we're going to do in this section is examine the dot product. Now we've been adding and subtracting vectors together, but what we can do now is it's almost like multiplication, but we call it dot product. And we have a vector, and when we do the dot product of two vectors, we actually get a scalar. So the dot product of two vectors is a scalar, or just a number. And this is the formula for the dot product, and let's go ahead and just practice that. So we have vector v and vector w, and the dot product, we're looking at these a values, the coefficients on I. So we have 5 and -3, plus the coefficients on j, -2 and 4. And when we add those together, we have -23. And that's our answer. So a scalar. We can do another example. We can do the dot product of v with itself, and that would be 5 and 5 plus -2 and -2, and that gives us 29. Okay. Now, something interesting that when we do the dot product of v with v, or any vector with itself, is that we actually get the magnitude of that vector squared. So the square root of 29 is the magnitude of this result here. Okay. So let's go ahead and kind of look down the rest of this. Now, these are things that are kind of intuitive, just we can flip the order and we still get the same thing. We can distribute, that's fine. Multiplying times 0 gives us 0, or doing the dot product with 0. And then with itself, the magnitude squared. And then with a constant, we can distribute that in there. Now there's another way that we can do the dot product. If I have vector v and vector w, I can look at the magnitude of each of those times cosine of theta. Now, theta is the angle between these two vectors. So if I have, and it's the smallest non-negative angle. So vector v and vector w, this would be theta, the angle between them. I would not use this angle. That's not the smallest angle, and it's non-negative. This is positive. So the formula for the angle between the two vectors, how do we find that angle then? And these are how we're going to be able to find it. Okay, so we have these formulas here. We can use cosine of theta, and then doing inverse cosine of that value gives us our angle theta. So let's go ahead and practice that. And it says find the angle between vectors v and w, and let's go ahead and do that. First, let's find the dot product of v and w. And so we have 6. Oh, you know what? Let's see. Let me go back here for a second. Let's actually just draw the vectors before we do anything else. Okay, so we have v is 3 and -2. And then w is -1 and 4. And this angle between them is what we're looking for. So let's just visualize that first before we start going after it. So now we can go back to what we were just saying. We want to find the dot product of v and w. And so that'll be 3 and -1 plus -2 and 4. And that gives us -11. And then we want to find the magnitude of v and the magnitude of w. And we can remember from the last section how to do that. So since they're both starting at the origin, we can do 1 squared we can do 3 squared plus 2 squared, and we can do 1 squared plus 4 squared. And that gives me square root 13 and square root 17. And so then cosine of theta is negative 11 over root 13 times root 17. Well, theta then will equal inverse cosine of negative 11 over square root of 13 times 17. And when we plug that into our calculators, we get about 137.7 degrees. Now, that makes sense because obviously it's more than 90 because it's past it here and past it here. So it makes sense that we would have something greater than 90. And that's a lot of times where the picture becomes helpful, is we want to make sure that our answer that we get makes sense with the picture that we have. Okay. Now I'm going to go ahead and flip the page. And we're talking about parallel and orthogonal vectors. Now you know what parallel means, and I'm just going to write the symbol above it. Orthogonal means the same thing as perpendicular, but that's the word we use when we're talking about vectors. So parallel vectors are two vectors that the angle theta between them is either 0 or 180. So if they're pointing in the same direction, the angle is 0. If they're pointing in opposite directions, so they both start here and this one points this way and this one points this way, they're still parallel, but the angle between them is 180. Now orthogonal vectors, the angle between them is always 90, and the interesting thing about orthogonal vectors is the dot product is 0. So let's go ahead and do an example. It says R, V, and W orthogonal. Now when you do this, I should see work. I should not just see yes or no. I should see you show me why that they are either orthogonal or not orthogonal. So we have these two vectors. We're doing the dot product, and we have 6 and 1 plus negative 3 and 2. And that's 6 minus 6 is 0. So therefore, vector V and vector W are orthogonal. And this is what I should see for your work here. So this is our answer, and there's my work. And that brings us to the end of section 6-7.